Hi, today we're gonna make a simple IoT using ESP32 as the web server. How to make it? Okay, let's go. Okay, we're gonna use ESP32 as the microcontroller and DHT11 and LED. Then we assemble it on a board like this. Move to the Arduino IDE. First, we're gonna program the DHT11 with including DHT library here. After that, of course, we define the pin 14 or auto pin output of the DHT32 as the DHT pin. And define the type of the DHT. Because there is have the DHT11 and DHT22, and today we gonna use DHT11. Let's define the DHT to initializations for pin and the type we were defined before in here, and just call this variable into this initialization. And the default setup setting the serial begin in 9600 baud rate. It's enough just for this monitoring. And call the DHT begin to start the DHT. In the for loop here, we're gonna read the humidity and temperature value from the DHT sensor. And let's add the code if for loop to read the value from the sensor DHT, we will print out like this. Or you can change it into auto alert. You can use anything. It's just a string. As if it gets the value from the sensor, it will print the value on serial monitor. After that, let's try it if it works or not. Just upload it to your ESP32 device. Let's move to connecting to the Wi-Fi. First, we add library of Wi-Fi.h. To connect the Wi-Fi, we have to add our credential of our network switch as the SSID and the password. Move to the default setup. Set serial pin to connecting to Wi-Fi. And then call the Wi-Fi begin to connect ESP32 to Wi-Fi using the perfect credentials. Okay, we're gonna add while here 2 waits until the Wi-Fi connection is established. It will print ... every half second if the ESP can connect to the Wi-Fi. And if it's finally connected to the Wi-Fi, it will print alert and the IP address as the local IP. It will be the link of the web ladder. That's how to connect to the Wi-Fi. Okay, and let's move into how to make ESP32 as the web server. First, here, we set the ESP as the Wi-Fi server. This initializes a web server and port 18. Port 18 is the default of HTTP port. In the default setup, we add the server button. It's to start the web server. Move to the for loop. This checks if a client, browser or device is requesting data from ESP32 server. Using Wi-Fi client, server available. If the new client connect, that will print alert like this. Then make request string to reach the HTTP request sent by the client. The serial println request, it means it will print the request for debugging. That's how to change your ESP32 as the web server. let's move to the handling LED control. Because we're gonna control the LED, we have to add LED pin. Here I use LED pin 2 ESP32. First we add string for LED state here, and I set it off. Let's move to the for setup. Here we define the pin mode of the LED pin as the pin output. Okay, and set it low, so it will turn off when it first running. After the for loop, we're gonna setting the request to turn on and off the LED pin. Here the coder will checks if the string /LED on exists in the HTTP request. Index 0f, here it returns the positions index of the substrings. If the substring is not found, it returns -1. If the result is not -1, it means the substring is present in the request, and the client wants to turn the LED on. After that, we send the high signal to the LED pin. It means this basically turns on the LED connected to that pin. After that, updates the LED state variable to reflect the current LED state. This value is used later to display the state on the web page. Okay, move to the DHT11 before. Here, the reading sensor data we can change into like this, so it won't looping in the serial monitor like before. Because here we gonna show the data in the web page, not the serial monitor. Let's move to the last part, generating HTML response. Here, I was prepare a simple web using HTML, and it still use data dummy. This is how it looks when we were running it in Chrome. And let's move into the Arduino IDE, and it will change like this. But when we move the code to the C++, we have to change the code to embed it into C++ program. And how it's gonna work. The ESP32, when acting as a web server, sends HTML code as a response to HTTP requests. Since the HTML is part of your Arduino sketch, it must be embedded as a C++ string types. Each line of HTML must be concatenated with plus to form a single continuous string. Why? The Arduino IDE and microcontrollers can directly interpret raw HTML as it is written in traditional web development. It needs to be embedded into the C++ code as part of HTTP response. In HTML, attributes like ID, class, or one-click like this often use double quotes. In C++ strings, double quotes are used to delimit the string itself, so any double quotes inside the string must be escaped with a backslash. Why? Without escaping, the compiler will treat the first closing quote it encounters as the end of the string, resulting in errors. Variables like temperature, humidity, and LED state are updated into your ESP32 code. These need to be inserted into the HTML dynamically, as their values change at runtime. The static HTML doesn't know the live values of your variables. By using C++ string concatenations, you inject the real-time values from your program into the HTML. JavaScript functions like update time and reverse data are included as inline script code. This code updates the web page dynamically without requiring a full page reload. JavaScript improves the user experience by adding live updates, like the current time, and reversing sensor data, without reloading the page. The JavaScript code is converted into a string and embedded in the same way as the HTML. The one-click attribute allows the button to send a request to the ESP32 server when clicked. The location.hoof here triggers a request to /LED on or /LED off, which is handled by your server code to change the LED state. The /first endpoint, handled by your ESP32 code, returns a JSON response containing the lost sensor data. This ensures that the display temperature, humidity, and LED state are always current. Why? Instead of reloading the entire page, the Fetch API fetches only the updated data in the background. This is efficient and provides a smoother user experience. After it's all done, of course, just upload it to your ESP32. And let's try it. This basic code, you can use this with another sensor, output, relay, or else, or anything else. Just change the interface of the web and it will be connected properly. That's all from me from this video. Hopefully I can help you with your project. You don't be sad to comment in my video or ask of anything of your problem with your project. I will gladly to help you. That's all I have. Bye bye.